AC motors are more commonly and widely used than DC motors in industrial applications and are available on three-phase and one-phase supply voltage systems. Most single-phase motors are less than 3 horsepower. On the other hand, three-phase motors are available in a range from a few horsepower all the way to several thousand horsepower. The three-phase motor, as its name applies, operates from a three-phase supply voltage. This type of motor is said to be an induction motor because the voltages, when applied, induce a magnetic field which makes the inside motor components rotate the shaft of the motor. You can remember how electrical power was generated from an alternator by transforming mechanical degrees into electrical degrees. Well, a motor does the opposite. It transforms electrical degrees into mechanical degrees, which are seen when the motor's shaft is rotating. Three-phase AC motors, as we'll see later, are also represented by the Y and delta configurations. They perform the inverse function of an alternator or generator system. The three-phase induction motor is primarily composed of these three basic parts: the stator, the rotor, and the end plates, which form the brackets of the motor. The stator is the stationary part of the motor, and therefore its name, and consists of several parts, including the frame type, according to NEMA standards. The stators consist of a group of individual coil windings where the rotor will rotate once the voltage is applied. These windings will be connected to the motor starter terminals. The rotor, as its name implies, is the rotating part of the motor and is constructed from either coils of wire wound on laminated steel, or it can be made from all laminated steel without any wire coils. If a motor's rotor has wire coils, it is called a wound rotor motor. A laminated motor rotor, which is most popular nowadays, is called a squirrel cage motor, because the design resembles the cage used for pet hamsters and the like, and therefore its name. As you can see, there are no brushes to pass current to the rotating parts, as was the case in a DC motor. The current is induced from the stator field to the rotor. The end plates or brackets house the bearings for the motor, which, depending on the size, will use sleeve-type bearings if it is a small fractional horsepower motor, or will use ball bearings if a large motor. Sleeve bearings require periodic lubrication, and some ball bearings in small motors will be what's called permanently lubricated, while the larger motor's ball bearings will require periodic lubrication. These end plates are mounted on both ends of the motor and are held in place by bolts and nuts tightened and secured to the stator frame. The squirrel cage Y-wound dual voltage motor has 9 terminal leads from the end of its coils for field connections. These terminals are numbered clockwise, starting at 1, 2, 3, and so on. The terminal connections T1, T2, and T3 from the starter are connected to the T1, T2, and T3 of the motor. The other connections are wired like this for a high voltage configuration. For a low voltage configuration, we would connect T1, T2, and T3 to the starter and also tie together with terminals 7, 8, and 9 respectively. Terminals 4, 5, and 6 will be tied together, essentially making a smaller Y. As you can see, a motor nameplate may indicate 2 terminal configurations, one for the low voltage and one for the high voltage. The squirrel cage dual voltage delta wound motor has 9 terminal leads. This 9-lead delta motor configuration also represents the terminal in number order in a clockwise direction, starting at T1, T2, and so on to T9. For a full voltage configuration, we would connect the terminals like this, where the T1, T2, and T3 terminals are connected to the motor starter T1, T2, and T3 connections. For a low voltage configuration, we would connect terminals 1, 6, and 7 together, 2, 4, and 8 together, and 3, 5, and 9 together. As we'll see later, if we interchange terminal leads, 1 and 3 will result in a change or revert the direction of the motor rotation from clockwise to counterclockwise, or, in other words, from forward to reverse.